Do you like s'mores? I love s'mores. And when you make a s'more, what do you need? You need 2 pieces of graham cracker. Okay, here's my graham cracker. And then usually I use like 2 marshmallows, nicely toasted, and mush them in there. And then half a chocolate bar, and then that other piece of graham cracker on top. Boy, that doesn't look very appetizing, does it? But anyway, if you think about one s'more, you need 2 graham crackers, let's say, 2 marshmallows, and half a chocolate bar. It's kind of making me hungry. Well, let's say we have a box of graham crackers. Let's say that one box of crackers contains, I don't know, 40 crackers. And a box or a bag of marshmallows contains 50 marshmallows. And we have a package of candy bars. Makes, let's say it has 8 bars in it. Okay. We can make only a certain amount of s'mores, and we're going to be limited by the ingredient that we have the least of. So 1 box of crackers, if we need 2 graham crackers, this would make 20 s'mores. And 50 marshmallows would make 25 s'mores. But 8 candy bars would only make 16 s'mores. So we're limited by the number of candy bars we have. Okay? We're limited by this. So we can only make 16 s'mores if we're following this recipe up here. So this is our limiting reagent. It limits how much we can produce, and the other important thing to remember is it controls how much we can produce. And this is also true for chemical reactions. The limiting reagent in a chemical reaction is the ingredient that we have the least amount of, and it also controls how much product we make. So with that in mind, let's go through another example and see what else we can learn about limiting reagents. So we're going to take the reaction a little less appetizing than the s'mores, but we're going to combine magnesium with some hydrochloric acid, and we get magnesium chloride and hydrogen from this. Okay. Let's say that I'm given 6 grams of hydrochloric acid and also 5 grams of magnesium. Okay, I want to find which one is my limiting reagent. Now this is important because really in most chemical reactions, especially those that are occurring in nature, when we combine our reactants together, they don't always occur in perfect proportions to each other. In other words, that both reactants are used up 100% when the reaction goes to completion. Usually they're not in perfect proportions, and we have more than we need of one and less than we need of the other. So we usually do have a limiting reagent. So this is a more realistic occurrence. So to find my limiting reagent, if you recall from my previous example, first thing we want to do is start with our given quantities. So I have 6 grams of hydrochloric acid, and I want to convert these given quantities into moles. So I use the molar mass of hydrochloric acid, which is 36.5 grams, and I find that I have 0.164 moles of HCl. And I'll do the same thing for magnesium. 5 grams of magnesium. I'm converting to moles. My molar mass of magnesium is 24.3 grams, and I end up with 0.206 moles of magnesium. Okay, so just to remind me that these are my given quantities, I've just converted them from grams into moles. So I'll label them again over here. This is what I have, my given. Now what I want to do is figure out what are my needed quantities. So in other words, if I'm given this much hydrochloric acid, 6 grams, or 0.164 moles of HCl, how much magnesium do I need in perfect proportion, according to this recipe, to react with it? So to figure that out, I'll start out with moles of hydrochloric acid. And to find out how much magnesium I need to react, this is where I'm using my mole ratio. And I have 1 mole of magnesium for every 2 moles of HCl. Okay, so I do my math here. I have 0.164 divided by 2, and this is 0.082 moles of magnesium that's needed. This is my needed quantity, okay, to react with the HCl. Now what I'm going to do is compare my needed quantity to my given quantity of HCl, so, or of magnesium. So I have 0.082 moles of magnesium. This is what I need. What do I actually have? I have 0.206 moles of magnesium. So I have more magnesium than I actually need. So that means, so when I compare these, okay, we're comparing these guys, my given with my needed. I have more magnesium than I need. So since I have more magnesium than I need, Mg is my excess reagent. It's the one I have too much of. And by default then, since magnesium is my excess reagent, HCl has to be my limiting reagent. So HCl therefore has to be my limiting reagent. Okay, I could prove that if I wanted. So I could go here and I could say, okay, if I have 0.206 moles of magnesium as my given quantity, how much hydrochloric acid do I need to react with it? And there's 2 moles of HCl for every 1 mole of magnesium. This ends up being 0.412 moles of HCl needed. And if I compare my needed quantity of HCl with my given quantity of HCl, okay, I need more HCl. I need 0.412 moles, but I only have 0.164 moles. I don't have enough HCl. And so that reinforces that HCl is my limiting reagent. Now, just as we learned in the s'mores example, boy, does that look ugly. That does not look appetizing at all. Sorry about that, guys. So we learned in the s'more example, the ingredient that you have the least of is what controls how much you can make. So my candy bars were what controlled how many s'mores I could make. In a chemical reaction, your limiting reagent is what controls how much product you can make. So that's why it's important to identify the limiting reagent, because you have to know what the limiting reagent it is in order to calculate how much product you make. So if I want to figure out, well, how much magnesium chloride and how much hydrogen can I make, I now can figure it out since I have my limiting reagent. HCl is my limiting reagent. I was given 0.164 moles. So now what I can do is find how much product is being made. And as I'm thinking about this, boy, I'm really scrunching this page up. So let's open up a new page. Okay. There we go. So I want to calculate the product given the limiting reagent. So my limiting reagent was HCl, and I had 0.164 moles of HCl. Okay, that was also 6 grams, but since I've converted into moles, that step has been done for me, so I can eliminate that step. So first of all, I want to find out how much magnesium chloride is being made. How much magnesium chloride is being made. So let me rewrite the reaction down here so we can refer to it, because we do need those coefficients. There we go. Okay. So I have 0.164 moles of magnesium. I want to find out how much magnesium chloride is being made. So I look at my mole ratio here. I have 1 mole of magnesium chloride for every 1 mole of magnesium. Okay, or I'm sorry, I just made a boo-boo. Let me go fix this. Okay, did you figure out what my mistake was? We should have moles of HCl here. So I have 1 mole of magnesium for every 2 moles of HCl. And then I want to find out how many grams of magnesium chloride that makes. My molar mass of magnesium chloride is 95.3 grams in 1 mole. So when I do my math, I have 0.164 divided by 2 times 95.3, and this should be 7.81 grams of magnesium chloride is produced. Okay, I can also figure out how much hydrogen is being made from my limiting reagent of hydrochloric acid. So I have 0.164 moles of HCl again. I want to find out how much hydrogen is being made. So I'm looking down here for my mole ratio. I have 1 mole of H2 for every 2 moles of HCl. And now I need to find grams. I need to convert to grams. The molar mass of hydrogen is 2.0 grams in a mole. These guys will end up canceling each other out, so I end up with 0.164 grams of hydrogen that's being produced. So now, just by identifying the limiting reagent, I was able to figure out how much of both products I was able to produce. So to summarize, and let's put this in red, in most chemical reactions, reactants are not in perfect proportion to each other. What does that mean? Usually it means there is a limiting reagent. Okay. Number 2, the limiting reagent controls how much product is being made. So therefore, in order to find, or in order to calculate amount of product formed, we have to identify the limiting reagent. So these are important things that I want you to put in your notes. You know, why is it important to find the limiting reagent? Because usually in nature there is one, and they control the amount of product. So if we want to find out how much product is made, we have to identify what that limiting reagent is.